Hello, students. Have you ever encountered a real-world problem that seems tricky to solve? Imagine you're at a fair, trying to figure out how many rides you can take and how many games of hoopla you can play with a fixed budget. This kind of problem can be solved using linear equations in two variables. In this video, we'll learn two powerful methods to solve such problems algebraically: the substitution method and the elimination method. These methods allow us to find the exact solution without any guessing, which can be very helpful, especially when the solutions involve non-integer or irrational numbers. Let's dive right in and see how we can use these methods to solve pairs of linear equations. Let's start with the substitution method, one of the most straightforward ways to solve a pair of linear equations. Here's how it works. Step 1. Pick one of the equations and solve for one variable in terms of the other. For example, if we have the equation x plus 2y equals 3, we can solve for x. That will give us x equals 3 minus 2y. Step 2. Now, substitute this expression for x into the second equation. This eliminates one variable, leaving us with an equation in only one variable. Step 3. Solve this new equation for the remaining variable. Step 4. Finally, substitute the value of the remaining variable back into the equation we used in step 1 to find the value of the first variable. It's that simple. Let's take a look at an example of this method. Consider the system of equations 7x minus 15y equals 2 and x plus 2y equals 3. Step 1. We solve the second equation, x plus 2y equals 3 for x equals 3 minus 2y. Step 2. Substitute x equals 3 minus 2y into the first equation, 7 open bracket 3 minus 2y close bracket minus 15y equals 2. Step 3. Simplify and solve for y, 21 minus 14y minus 15y equals 2, minus 29y equals minus 19, y equals 19 over 29. Step 4. Now, substitute y equals 19 over 29 into x equals 3 minus 2y, x equals 3 minus 2 open bracket 19 over 29 close bracket is equal to 49 over 29. So, the solution to the system is x equals 49 over 29 and y equals 19 over 29. This method is helpful when you can easily isolate one variable in one of the equations. Now, let's look at another algebraic method, the elimination method, which is often more convenient when the coefficients of one variable are easily manipulated. Here's how it works. Step 1. Multiply both equations by suitable numbers so that the coefficients of one variable, either x or y, are the same. Step 2. Now, subtract or add the two equations to eliminate one variable. This will leave us with an equation in one variable. Step 3. Solve the resulting equation for the remaining variable. Step 4. Finally, substitute this value into one of the original equations to find the other variable. This method is efficient when dealing with equations that can be easily manipulated. Let's solve a system of equations using the elimination method. 9x minus 4y equals 2000, 7x minus 3y equals 2000. Step 1. Multiply the first equation by 3 and the second by 4 to make the coefficients of y equal 27x minus 12y equals 6000, 28x minus 12y equals 8000. Step 2. Subtract the second equation from the first to eliminate y. 27x minus 28x plus minus 12y plus 12y equals 6000 minus 8000 minus x equals minus 2000, x equals 2000. Step 3. Substitute x equals 2000 into the first equation, 9 open bracket 2000 close bracket minus 4y equals 2000, 18,000 minus 4y equals 2000, 4y equals 16,000, y equals 4,000. So, the solution to the system is x equals 2000 and y equals 4000. To sum up what we've learned today, the substitution method is a great way to solve when you can easily isolate one variable. The elimination method is often more efficient when you can manipulate the equations to eliminate a variable. Both methods are highly effective for solving systems of linear equations algebraically. These techniques are essential in algebra, especially when dealing with real-world problems involving multiple constraints. I hope now you understand how these methods work. In the next video, we will explore more advanced techniques in solving linear systems. See you next time.